Hi ladies and gentlemen, it's Ms. Skokin. We're going to talk about section 5-7, radical functions, and as usual we're going to start with a warm-up. So turn the video back on when you are ready to check your answers. You probably recognize number 1 as a parabola 2 units up, so the domain is all real numbers and the range is all values of y that are greater than or equal to 2. And question number 2 is a cubic function with a vertical expansion by a factor of 3. Domain is all real numbers and range is all real numbers. When we look at 3 and 4, we are thinking back into what a vertical translation looks like and what a horizontal translation looks like. And you probably have guessed that that's because we're going to be looking at radical functions and their translations. Our objectives are to graph radical functions and inequalities and transform radical functions by changing parameters, and that's those dilations and translations and reflections. In terms of vocabulary, we have radical function and square root function. So you remember the parent function y is equal to x squared, and it's the blue one in the grid on the left. When we when we reflect across that line y equals x, we're going to get the inverse of the function that we started out with, but the inverse is not always going to be a function. And as you can see from the red, the sideways looking parabola, the f inverse of x, it's plus or minus square root of x, and it's not a function because it's not going to pass the vertical line test. In the right-hand grid in the blue, we see the cubic parent function, y is equal to x cubed, or f of x is equal to x cubed. And in the red, we see the inverse of that. So it's that sideways reflection over y equals x, the line y equals x. This one is a function. It does pass the vertical line test. So sometimes a function will have an inverse that is also a function, and sometimes it won't. Read through the notes on this screen, and if you need to pause the video to take notes, jot things down, you're more than welcome to do that, and then turn the video back on when you're ready to continue. Okay, we're going to take a look at example 1, and it says graph each function and identify the domain and range. So what I would like you to do is create an XY table and pick some convenient x's, and then plug those x's in, get the resulting y's, and graph those points. You can join up the points and think about the domain and range, so you can think about exactly whether you have an arrow on both sides or just on one side of your function. Turn the video back on when you're ready to check your answer. Check the XY pairs that you ended up with. They should be the same as these, and check out your graph. Of course, depending on the scale, it might look a little bit different, but it has the same basic shape. And the domain is all numbers x that are greater than or equal to 3, and the range is all numbers of y, or all numbers y that are greater than or equal to 0. So we can't have a negative under the radical, so that's one of the constraints of this function. Once again, in question B, what I would like you to do is make a table of values, an XY table, pick convenient values of x, and then find the resulting values of y. In this case, because it's a cube root, we're not restricted by having only positive numbers under the radical symbol or in the radicand. So we can have negative numbers as well. So once again, pick convenient values and then graph the function, and turn the video back on when you're ready to check. So we've got our XY table, check your ordered pairs, we have our graph, and we have the domain and range, which are both all real numbers. If you have a question about this one, please jot it down in your notes with a Post-it and we'll talk about it in class. When it comes to transformations, the transformations that take place on radical functions are exactly what we saw in linear, quadratic, polynomial, and exponential functions. So what we're going to take a look at is specifically with regard to the square root function, which, if you remember back when we learned parent functions way back when, it looks kind of like a little wing that starts at 0, 0 just on one side. So take a look. You may want to make some notes on here just to remind yourself of that, the different places, the different ways that transformations are indicated on functions. And whether it's a translation, remember a translation is always going to be addition or subtraction. A compression or an expansion is going to be based on multiplication, and a reflection is going to be a negative. And once again, these haven't changed. The placement hasn't changed. It's all comparable to what we've learned in the past. You just need to apply it now to square root functions. In example 2, we're going to take a look at transforming square root functions. So what I'd like you to do is first graph the parent function f of x is equal to square root of x, and then describe the transformation that is going to be made, and then graph the function. Okay, so here's our g of x. It's square root of x plus 5. Once again, you are going to want to describe and then graph. So work on that and then turn the video back on when you're ready to check your answer. Okay, so it's a translation 5 units up. That's a vertical translation. And you can see it looks exactly, g of x looks exactly like f of x. It's the same size and shape. The difference is it has been translated 5 units up. That's what you should have written down in your notes. Here's a great visual diagram of exactly where we see the different transformations and how they appear. Just like when we learned quadratic, that h and k is going to be pivotal to give us the horizontal and the vertical translations. The a and the b are either vertical or horizontal dilations, and then the sign of a and b, if we have a negative, then we know that that's going to indicate a reflection. If a is negative, it's a reflection across the x-axis, and if b is negative, it's going to be a reflection across the y-axis. Let's take a look at example 3. Another example, first of all, you're going to graph f of x is equal to square root x, your parent function, as the guide, and then you're going to describe the function that, or the transformation that makes g of x from f of x, and last of all, graph it. Turn the video back on when you are ready to check your answer. Anytime you have transformations like this, you can take them in one at a time, or as you can see, we had f of x and we did both the reflection and the horizontal translation to come up with g of x. So again, if you have a question, write it down and we'll talk about it in class. In example number 4, what we want to be able to do is write the transformed function based on the description of the transformations. So we're going to start with the parent function f of x is equal to square root x. We're going to reflect it across the x-axis, compress it vertically by a factor of 1/5, and then translate it down 5 units. If you need to go back to the chart, take a look at the chart on on page 30 of your notes, and use that to help you write the function rule for g of x. Turn the video back on when you're ready to check your answer. So here are some hints. You can see the way that you start putting that together, and pause the video if you had some trouble with this and you want to take notes on it. And using the kind of the model that we had on page 31, you can see that when we put it all together, we end up having this function rule for g of x. So once again, if you have any questions on this, we can talk about it in class. Hopefully this was relatively comfortable because of all the work that we've done with transformations previously. Although this is not a beautiful picture, you can see what this looks like. This is the original function, the f of x parent function, and then our g of x translated or transformed function. Example number 5 is a real-world application. So what you need to do, of course, is pause the video, read it carefully, and try to work it out by yourself. This one is very straightforward, is I guess the best word. Very straightforward, and you should find it pretty comfortable based on the different transformation work and its simple transformations that you see in this example. So turn the video back on when you're ready to check out the next steps. So we recognize that our function d of a is the cost function c of a plus the $6 to install the glass. So you can see that in step 1. In step 2, we're going to actually plug in our area, the 192 square inches of glass, so that we can come up, once we calculate $13.13, including installation. That's it for our notes for section 5-7. So I'll see you in class.